Well, welcome back to Coalesce 2022, day number 3. So let's go ahead and jump into what's happening today.
Every company here has got their own unique story, their own little twist of things they like and problems they're trying to solve. So we're learning just as much from lunch conversations as we are the sessions.
Well, it is officially day number 4, and you are here. You are here in person with us in New Orleans, but I definitely want to give a special shout out to the online virtual community. The number of purple fiery emojis in the community Slack channels just made my heart smile. So for all of you who are still joining us and you're virtual, we have some of you in London, some of you in Sydney, I even seen Belize. We thank you for being here. And for those of you who have returned in person, we are not ending just yet. We have so many more keynote presentations, ecosystem talks, and community talks that you can experience today. Now, I don't know about you, but yesterday, the day before that, was truly not just mediocre, it was magnificent. Anybody here stop by Storyville Hall by a show of hands? A few of you, some of you said 2 hands. I saw some of you really interacting with the different partners that we have there. And Storyville Hall will be happening again today, so make sure you visit that when you get a chance. Now, if you've ever wondered why SQL and Python go perfectly together, this next session is just for you. Torsten Grabs, who is the Director of Product Management from Snowflake, is here to share all the details. Now, Torsten currently serves as Director of Product Management for Snowflake. There, he heads product management for Snowflake's data engineering, data lake, and data science workloads, as well as the Snowpark developer experience. Now, before joining Snowflake, Torsten has an awesome, amazing resume before he got there. He actually spent more than a decade at Microsoft in the SQL Server product group in Redmond, Washington. He served in different roles in software development and product management. Here's a fun fact that you may or may not know about Torsten. He actually holds a PhD in computer science from Swiss Federal Institute of Technology in Switzerland. So technically, we should be calling him Dr. Torsten or Dr. Grabs, whichever one you want. Also, he loves the mountains and ocean, and Seattle offers both, and that's where he resides. He likes to take advantage of the mountains for skiing and hiking, and also the ocean for sailing. But more importantly, one of his favorite foods is a good brat sausage. But enough about that. Let's go and hear why Python and SQL go so perfectly together. Put your hands together for Dr. Torsten Grabs.
Thank you so much. Thank you so much. It's great to be here, and it's great to see you all. Thanks for joining in the early morning hours to talk about dbt and Snowflake, but also to tell you a little bit more about why I think SQL and Python are actually a wonderful combination. So in terms of topics and agenda that I want to cover today, here's a brief overview. I'm not assuming that you all are necessarily familiar with Snowflake and Snowpark, so I want to give you a brief overview about Snowflake and the data cloud. After that, I want to share a little bit of the motivation that convinced us to invest into additional programming languages beyond SQL, which has been our bread and butter business, and talk about the reasons for cross-language collaboration and why it is an important topic for every organization. After that, I'll walk you through some of the let's say, implementation details of Snowpark, which is our cross-language environment in Snowflake that hosts our Python support. And then last but not least, we're going to put all of these pieces together and put dbt on top of Snowpark and Snowflake. And I'll walk you through some use cases that I really find interesting and compelling to show you that across language interaction and collaboration across SQL and Python with dbt and Snowflake. So let's start with an overview about Snowflake. Snowflake was started about 10 years ago by our founders, Benoit and Thierry. And when they started, there were a couple of interesting things going on in the industry. The first one was in the enterprise data warehousing space, a lot of companies were running their systems on dedicated hardware in their data centers. And similarly, there were large systems running Hadoop for data lake and big data processing scenarios in the data centers of the world. At the same time, also the public cloud became popular, and it started to offer storage and compute as separate services that you could essentially buy from the cloud infrastructure providers. And that led to a moment in the industry where you could rethink data architecture from the ground up and design systems for big data processing and data warehousing for the cloud, built and designed for the cloud from the ground up. And that's what Snowflake did as well. So we started building out an architecture that in a very disciplined way separates compute from storage on the public cloud infrastructure providers. And that allowed us now to bring previously different systems and separate workloads together on the same platform while still providing very, very compelling benefits. Like, for instance, you can very easily do workload isolation. Teams can collaborate on the same data sets, but your data stack is much simpler. You don't end up with a lot of silos, and you avoid a lot of unnecessary complexity. All of that is in Snowflake, a managed service in the cloud. It's available globally, across regions, across cloud providers. And now it also offers you cross-language interoperability capabilities with support for SQL, Python, Java, and Scala. And last but not least, the data cloud gives you the ability to collaborate on shared data globally in the data marketplace. So let's double-click on that data cloud aspect for just a moment. There are three main ingredients that I typically mention when talking about the data cloud. The first one is the data itself. The second one is applications. And the third is services. And with the data cloud, you are then able to break down silos within your organization, but also collaborate across your partners and customers in the data cloud and even include third parties. The data cloud has two key elements to it. The first one is the content itself. So that is the data sets, the applications, and the services that you can find on the data marketplace. And underlying that is the second key element. That's obviously the Snowflake platform that we just talked about that is built on the public cloud providers with the architecture that I just touched on. Now, the best part here is that every Snowflake customer immediately has access to their Snowflake account into the data cloud and can benefit from all these capabilities. Okay, let's switch gears here a little bit and start thinking about why can SQL not be the only language. So when we started Snowflake, we had our hands full just building the best possible experience for SQL as a programming language. And that is great, and it still is great today because SQL remains very, very popular. But as we started working on additional and more workloads, we started encountering different personas that had different preferences. And I have a few examples here on this slide, as you can see. So imagine a data scientist. They're probably operating in a Jupyter notebook, writing Python code, using some of the Python libraries, and using familiar programming concepts like, for instance, data frames. So that is not necessarily a scenario where SQL would resonate as a programming language. Or think about a data application developer. They might be working in an IDE like Visual Studio Code, IntelliJ, or Eclipse, writing Java code, Scala code. And last but not least, you may have data scientists, ML engineers that are working across the stack in different languages. So with these examples, it became pretty clear to us that we have to venture beyond SQL and start adding support for more programming languages to the platform. I want to motivate this with a few more examples here. Here's the first one that I've put together, which is kind of a high-level overview of what might be a typical data pipeline in the enterprise. You can see we start with some raw data on the left-hand side. That could be files. that you then ingest into something like a staging table. In Snowflake, you can do that in a continuous fashion through capabilities like, for instance, Snowpark. And then as new changes are showing up in that staging table, you might want to consume those changes through something like change data capture into a piece that processes these new rows, shapes them in different ways before storing the results in a table that serves your BI stack. Now imagine for a moment that the piece of code that does the processing of the new rows is a little bit more sophisticated and is actually done by someone in your organization that prefers other programming languages than SQL, let's say Python for a moment. How could you still host that on the same platform and not end up with a fractured data stack where one part is the SQL processing and then you have a different silo where that Python processing happens? And that's a dangerous situation to end up with because then you're shuffling data around and data governance and security is very, very hard to manage. So here's another example along similar lines. So imagine, again, a data scientist working, let's say, in a Jupyter notebook, working on a machine learning model. That is typically, as I mentioned, is happening in Python. The result of that work then can be a Python model, a Python package, that now needs to get deployed across the organization. It can end up in a data pipeline like the one that we saw on the previous slide, but it could also go into a report that is done by a data analyst or a dashboard where they want to invoke the model that has been built by the data scientist to do something like, for instance, customer churn prediction, right? And if this report is written in SQL, but the machine learning model is in Python, you have a language boundary that you need to cross. So this is another example where it becomes really beneficial if you have a platform that supports these different programming languages in one place. Here's some data that always strikes me when I look at it, and particularly the data point on the right-hand side here is the one that I find intriguing. And it is a statistic from Forrester that says that machine learning practitioners still struggle to a large extent, more than 60%, struggle to productionize the result of their work. So deploying their machine learning models into production in an organization is still surprisingly hard. And reasons for that, there are many for that. I'll mention some. The first one is what we already touched on, that for instance, the machine learning model might be in Python, but your mission critical infrastructure runs on a Java stack, so you may have to re-implement your machine learning model in a different programming language. That takes time, that takes effort, and makes it complicated. Wouldn't it be much better if your mission critical infrastructure could actually run Python itself? And we also touched on the alternative. You could run separate silos, separate systems, one for Python and the other one for Java. Again, that makes security governance complicated, and you have to manage redundant copies of your data and different systems with different philosophies and different concepts. So we tried to simplify that, and we tried to remove complexity across that wherever possible. And our solution to that is what we call Snowpark. And now here today, I want to talk mostly about Snowpark for Python. But Snowpark, if you think about it from the top level, essentially has two layers that you can see on this slide here as well. The first one is at the bottom of what I call server-side here on the slide. And that is really server-side extensibility, where we have extended the Snowflake compute infrastructure, our compute warehouses, with the ability to host additional language runtimes beyond SQL. And that is traditional database extensibility. So we've built a piece of infrastructure that allows us to host sandboxes, and that gives us the ability to relatively quickly slot in new language runtimes. We've started a couple of years ago adding Java virtual machines as our first additional runtime beyond SQL, and that has been in production in GA for quite some time. And then earlier this year at our Summit conference, we announced the public preview for our Python extensibility, which is the second language where we followed that paradigm that we added a language runtime into the stack on the server side. Now that is being complemented by the top level that you see on the slide here, which is the client side. And the client side provides you an SDK with a number of APIs. Probably the most prominent one that I call out here in terms of the APIs is a data frame concept that Snowpark introduces. And that is inspired by other data frame concepts, like for instance from Pandas and PySpark. So if you're familiar with those, you'll find Snowpark data frame APIs also very, very familiar to you. Now, the great piece about these two layers is that they are actually tightly integrated. So you can write a data frame piece of code on the client side. When you execute that, the SDK will compile the data frame program into essentially a SQL skeleton that runs on the server side. And in those places where you invoke a piece of custom code in your client-side program, we will push that custom code down into the extensibility infrastructure on the server side, and then from within that SQL skeleton that runs on the server side, escape into the language runtimes to run your custom code. And that is built around concepts like, for instance, user-defined functions, user-defined table functions, and also stored procedures, which are some of the core concepts that we've introduced at the extensibility layer on the server side. So this has a number of benefits that I try to summarize on this slide here. So the first one is you are dealing with very familiar programming concepts. I was mentioning the data frame APIs. That's probably the key one to call out here. The second one is the rich ecosystem, now focusing on Python in particular, is the rich ecosystem of the Python community and its libraries and packages that you have immediate access on with Snowpark. So one of the choices that we have made, and we'll talk more about this on the next slide, is that we've deeply integrated with Anaconda to provide you an easy experience around Python. And the last piece here that I want to mention is the secure processing environment. So we have taken a lot of time to make sure that the sandbox infrastructure that hosts the language runtimes is highly secure. I'll give you a few examples, a few concerns here that we were thinking through when we were designing that layer. The first one was, obviously, there can be problems around data exfiltration if you don't govern network access tightly from these sandboxes. So one of the design decisions that we made was we disallow by default outbound network access from these language sandboxes. And that gives you an additional level of security when you run your custom code on the Snowpark infrastructure. There are a few other examples on that one. Here's a little bit more data around the security concerns. I pulled this from the recent report about the state of data science from Anaconda, and it just highlights that security concerns are still one of the most common roadblocks for productionizing ML code. And I'm using ML code and ML models here as a synonym for essentially Python code. And the main concerns are around unchecked network access, concerns around unwanted data exfiltration. And that's why we spend so much time to secure our sandbox and disallow outbound network access by default. So those are some of the design choices that we have made to really give you an additional level of confidence and comfort when you're running your custom code in addition to SQL in languages such as Python or Java on Snowpark. So talking about Anaconda and the Anaconda integration for a moment here as well. So we have partnered with Anaconda, and we decided to deeply integrate with the Anaconda distribution. And the motivation for that to make it easier, to make Python easier to use on Snowflake. So a lot of customers struggle with dependency management across different Python packages. And that is an aspect that Anaconda deals well with. And that was one of the reasons why we decided to pre-install the Anaconda, pretty much most of the Anaconda defaults channel packages into Snowpark. So that simplifies dependency management for you. But also in addition to that, Anaconda is vetting and curating those libraries for you. It's running security checks over it. So this provides you with another layer of security benefits on top of the sandbox environment that we just talked about. So with that, let's start putting those pieces together. So this slide here should look familiar, except for the addition of DBT that I now put on top of this. What I want to do is that walk you through a number of really interesting use cases, at least for me, that hopefully make it clear for you that adding Python to SQL in the context of Snowflake and DBT is really straightforward. And something that I really enjoyed when looking at the integration of Python into DBT was that it allows you to freely compose between SQL and Python across language boundaries with models in dbt. So you can choose to implement a part of your data pipeline in a SQL model and then have another part of that same data pipeline implemented in a Python model. And you can then bring all of these pieces together in one end-to-end data pipeline that you can run on this stack that we're just looking at. So here is a first example that I put together that I found really meaningful. With Snowflake over the last couple of years, we've actually added support for unstructured data management to Snowflake. And we've built on the existing concept of what we call a stage, which essentially provides you with a place where you can store files. We're looking at files as the most common abstraction for unstructured data. And imagine now you are essentially storing these unstructured data files in a Snowflake stage, and you have corresponding more structured metadata with that. If you want to run a data pipeline across that, you might want to just simply start out with a SQL statement like the one that you see on the left here. And this one just looks at the files in the stage, and another table that has more structured metadata around it does a join over this using, for instance, a timestamp column on it. And one of the key advantages of the unstructured data management in Snowflake now is you can actually promote a URL that gives you the location of the file. You can promote that out in your SQL statement and then pass it down to subsequent processing steps that may want to crack open the file that sits in the unstructured store. And this is exactly what the second kind of pseudocode example shows here. And now that makes the switch from SQL, which we have on the left-hand side, to Python, which is on the right-hand side. And the reason why I chose Python for the right-hand side is that you'll probably find a plethora of different really useful packages in the Python library ecosystem that can deal with all sorts of unstructured data, all sorts of file formats. You'll find it really easy to find a compelling library that if you pass in the location of the file, you can actually process the content of the file and do really meaningful things with it. So imagine a scenario, for instance, like object recognition over images. You'll probably find examples for that in the Python libraries. Now, what this second model does here, the Python model, it actually uses a dbt reference that points back to the SQL model on the left-hand side to essentially pick up from where the SQL model left its things. And it grabs that file URL and passes it into a user-defined function. And that user-defined function is where I'm using a Python package to then crack open the unstructured data and extract additional pieces or additional value from the unstructured data. And that's what you're seeing here on the right-hand side with the call into this myfile UDF, where I'm passing in the locator for the file, which then points back into the stage where the file is stored. Now, when you run this, we'll do all the processing in Snowflake. Every piece of code here that you see here, except for the orchestration in dbt, is pushed down into the Snowflake engine. And we'll run a compute graph that in places will have just SQL code, and in other places escape into the Python runtime wherever we are going into specifically this user-defined function that you have implemented here. And that is great because it gives you a consistent processing environment with Snowflake. The data does not leave Snowflake, so data governance and security are much less of a concern as compared to a situation where you send your data into a different stack for the Python processing. And it can also benefit from the elasticity, scalability, and performance benefits from Snowflake because the Python code that we run in Snowflake runs on exactly the same compute infrastructure that we also do our SQL processing on. So it's literally the same compute nodes that we are using for that and where the Python runtime runs. And then the final result then from this processing, you may decide to store that in a separate table again for further consumption downstream in your data stack. So net, if you look at this pattern, it hopefully strikes you as really elegant in terms of the composability that you have across the different languages, SQL on one hand and Python on the other one. The ability to cross-reference between these different language environments with the dbt references. And then the compelling runtime part of that, where all of the data processing at scale happens within the Snowflake engine. Let's jump to another example here, kind of leaving the unstructured data processing, leaving that aside maybe for a moment here. So the second example that I picked here follows pretty much the same pattern, but is a slightly different use case. In this case, I'm looking at an example with a metrics store, and you see the same pattern play out again here. So you have a piece of SQL code on the left-hand side. You go against probably a number of tables with your raw data that you want to do some processing over, and that's probably very easy to write in SQL. So you've decided to implement that with a SQL dbt model. And you can run those transformations over there, but then also use Python for more sophisticated calculations that you might want to do for some of the metrics, because you find the easiest packages for doing that in the Python community with some of the libraries over there. And the pattern is very similar to what we had on the previous slide. So you would implement that custom calculation where you include the Python package in a user-defined function and then refer to that user-defined function from a piece of data frame API calls in Snowpark in the Python model. And again, you have that same benefit here, that it is very easy to cross-reference between the different language environments with dbt reference. So you can see how the right-hand side here, the Python environment, refers back to the SQL model on the left-hand side. And then once you run that and you get the results, then you may decide to push the results of all of that processing into a set of different metrics tables that many of you probably would then serve into a BI stack using things like Tableau or Power BI or our Snowside dashboards natively in Snowflake. And then, like on the previous slide, if you run this at runtime, it will sit and run on the Snowflake engine in the blue part that you see at the bottom here. So none of the data needs to leave the processing boundaries of Snowflake. Again, highlighting here that there are security, governance, and obviously performance and scale benefits to that as well. All right, so here is the last example that I've put together to illustrate this pattern, and it's around feature stores. And again, the basic idea is you use SQL for those areas where that is the easiest language for you to work with. You can see the raw data processing is happening there. But then for a feature store, for some of the more advanced features, you might want to invoke some of the Python packages with the popular machine learning frameworks. I listed a few of them here, like for instance XGBoost, which is very popular, scikit-learn, PyTorch, or TensorFlow. Those are the most common ones that we see. They're all pre-built and pre-installed through the Anaconda channel, so they're readily available for you in Snowpark for Python, and you can refer to them from the Python model that you implement with dbt to do that processing. And the idea really here is to layer on top of the SQL processing, on top of the SQL model, and inject custom code in Python for those metrics where you would benefit from these machine learning frameworks. And the result of that processing when you run that is, again, a piece of data frame code. It executes on the Snowflake runtime. And the results for that, you can now decide to store into a regular Snowflake table. But you can also decide to use a new capability in Snowflake that we started to talk about at our Summit conference, which we call a hybrid table. The hybrid table is interesting in particular in the context of feature stores because it provides you with a much more compelling latency profile than our regular tables. So our regular tables are probably a good fit for batch processing in the context of feature stores. But as soon as your latency requirements get stricter, then a hybrid table might be a better choice for you in order to serve up your features because the latency profile is dramatically better on a hybrid table. And that allows you to move towards some online feature store work on the basis of these hybrid tables. OK, again, kind of summing up, you saw on these 3 slides essentially the same or a very similar pattern repeat itself. And that's what I'm generally excited about is that ability to compose across the different languages and use whatever language is appropriate for a particular model in dbt and then stitch these different models and different languages together for overarching end-to-end data pipeline implementations. And I think that is extremely powerful. And in the combination between dbt and Snowflake, I think you also have a very compelling stack in terms of runtimes that you can lean on. So with that, let me switch gears here a little bit and talk not so much about the intra-organization data pipelines. This is what we spent most of the time on the previous slides. But let's think maybe a little bit for a moment also about the data cloud and data value chains at a more global scale. So with the Snowflake data cloud, I mentioned initially that every Snowflake account has immediate access to the data marketplace and the data cloud in Snowflake. With the data cloud now, it becomes much, much easier for you to also think globally about data value chains across organizations, across your customers and partners and other organizations. And that is not limited by cloud providers or the regions that you're in. We are doing all the heavy lifting on our end to bridge the gaps between the different cloud providers and the different regions and make data assets available globally. So then you can start essentially building a local data pipeline within your organization, publish the results of that into the data cloud, and in the data cloud share it with consumers, share it with partners and customers that can then layer on top of that with their data pipeline where they add their value on top of that. And you continue that pattern to then build a global value chain. And that becomes really easy, really compelling when you do that with dbt, with Python, and with Snowpark in the data cloud. So I want to encourage you to also think about that because I think it's going to open up a lot of opportunities for you all across these different languages and across organizational boundaries. And I'm very curious to see what are the data pipelines, what are the data value chains that you come up with and that you build with these tools. And with that, actually, I'm at the end of my presentation. So thank you so much. Hope this was insightful for you. And I have a few pointers for you if you want to learn more about the details for that. So there were two presentations by team members from the Snowflake crew here. The first one is Edda Johnson, who had a talk on Monday about empowering Pythonistas. That talk should be available online already. Like the second one from Miles Atkins. For those of you where that feature store example resonated that I had on one of the later slides, go please check out the talk from Miles Atkins because he's going to double click specifically on that feature store idea that I shared with you here. And then last but not least, Jeremiah Hansen has put together an awesome quick start lab just right in time for Qualys to show you how you can do data engineering with Snowpark, Python, and dbt. And that, if you want to really get a quick start on what I showed to you in some of these slides about composing between Python and SQL, go check out the quick start lab from Jeremiah Hansen. All right, thank you so much, and back to Quinn.